So this is lesson 9. This is going to be the last lesson that we have in unit 1 because we combined units lesson 6 and lesson 10 yesterday. Today we're evaluating and comparing algebraic expressions. Now, what is an algebraic expression? Yes.
Isn't it like an expression that has variables in it?
It's an expression that has variables in it and or numbers. It could have exponents. Who's the tip? Who's the tippy tapping person? Jacob. I'm like looking around and you're in tippy tappy land on your desk there. No tippy tapping. In Spanish? No tippy tappio. Okay. Evaluate and compare algebraic expressions. Elizabeth is right. An algebraic expression is an expression that has variables and numbers along with mathematical operations. If it just has numbers in it, it's called a numeric expression, right? It's just a numeric, but an algebraic expression is an expression that is going to have variables and numbers in it. So we're going to evaluate and compare, tell the value of, and compare algebraic expressions. Evaluate means tell the value of. 2 plus 3, evaluate it. 5, right? What is the value of an algebraic expression when we're given certain things? Okay, so this is the definition that I just gave you. It's any expression containing only numbers and operations is a numeric expression. Okay, so this is something for, fill in the blank kind of question for the definition quiz on next week. Any expression containing only numbers and operations is a numeric expression. That's pretty easy to identify, right? But if we involve numbers and variables, then it becomes an algebraic expression. It's an expression with variables and or numbers that use operations such as addition, subtraction, multiplication, or division. So an algebraic expression is where we throw variables into the mix. Now, up to this point, we've done some algebraic expressions, right? We just did one in the bell work that involved exponents, and we talked about simplifying expressions with exponents a little bit earlier in the chapter. Today we're going to evaluate, be making substitutions and evaluating. Nothing new here. Today is pretty easy. We're just going to be using variable expressions instead of numeric expressions to start off with. And then we're going to make substitutions and turn our variable expressions into, our algebraic expressions into numeric expressions and evaluating them according to el order of operations O. That's right. That's the order of operations in Spanish. Okay, for Abby. Example 1. Here's what we're doing. We are going to evaluate the expression that is given here when x equals 3 and a equals 1. Okay? Now, what kind of expression is this? It's an algebraic expression, right? Okay, so they're telling me to find the value of this algebraic expression when x equals 3 and a equals 1. So what is that process going to look like? What am I going to do? I'm going to substitute. In the place of x, I'm going to put 3, both places. And in the place of a, I'm going to put Juan. It's Juan. Okay? So we'll have 1 times 3. Now we've got this expression. So I have turned an algebraic expression into a numeric expression by making substitutions of variables given, and now I have to evaluate it. Tell what it is equal to, right? So 3 times 3 is 9, 12 plus 3. And that gives us a value of...
Would that not be negative 4 times 3?
Yes.
So, what it, oh, I did that one in my head. No, because I was confused earlier, because, like, I didn't know if that was supposed to, like, put the negative with it, because when we did exponents, like...
Yes, and that's and we're going to look at one in just a second that's going to make your question a lot more relevant than this one. But yes, it is negative 4 times 3, which is negative 12. All right, so 9 minus 12 is negative 3, and negative 3 plus 3 is 0. Right?
0.
All right, so we have substituted values into this algebraic expression and evaluated it. Yes?
So addition came before subtraction?
You do addition and subtraction from left to right.
Oh, okay. I was thinking PIMDOS.
But even if you add first, as long as you take the signs with the number, Jay, 9 plus 3 is 12. 12 minus 12 is still 0.
Because surprisingly, that did not end up on the test, or else I would have gotten about 4 problems wrong.
Now, what you did incorrect here, Jay, I just looked at your work. What you did incorrect is you added these two values first. But listen, you can do that as long as you do it correctly. What's negative 12 plus 3?
9.
Negative 9. So the mistake that you made, Jay, isn't one of adding before subtracting. The mistake that you made is not recognizing that the sign in front of 12 makes it negative 12. So negative 12 plus 9 is... negative 12 plus 3 is negative 9, and that's where you messed up. Okay? And there were problems probably like that on the quiz. You just didn't make the mistake. Well, I mean, it's okay to add first. That's what I'm telling you. You just have to add negative 12 plus 3 and not this. What you did is this. You added a parenthesis to the problem right there. That's how you perform the operation. And that parentheses isn't given to us. Now that would mean add the 12 and the 3 and then subtract. Okay? So there's a lot of different ways you can get sideways on these problems. Have a look at this one. Evaluate this algebraic expression. If y equals 2 and z equals 4. The first step always is to make the substitution. So we'll have 3 times 4 minus 2 squared minus 4 times 2 cubed. Then we'll follow the order of operations. How many terms do we have in this expression right now? How many terms are here? 2 terms, just making sure you're being mindful of that. So I can do everything in this term and everything in this term, and I'm safe, right? So 4 minus 2 here gives us 2, and 2 squared is equal to 4. 4 times 3 is 12. Minus 2 cubed is 8, and 8 times 4 is 32. And then 12 minus 32 is equal to negative 20. All right? Everybody okay with that? Anybody get sideways on that one? Mary Helen, did you get that one? Okay. I just saw you right, and I want to know where the mistakes are. Where are we prone to making mistakes? If you can identify where you're prone to making mistakes, then you can eliminate those mistakes and become a better student, right? So if we need to own the mistakes and come with it. Okay? Compare expressions here. If A equals 4, B equals 3, use less than, greater than, or equal to. So this is just going to force us to make the substitutions in these 2 algebraic expressions and then compare them. At the end, we want to make a comparison. So evaluate and then compare. So 3 times a to the 4th, that's 4 squared, plus 2 times b, which is 3, minus 4 times 4 cubed. Nope, I messed up. See? B is 3. On the right side, we'll have 2 times 4 squared times 3 squared. Now, that little mistake that I did, and I hear some of you guys multiplying this in your head as you go, that little mistake that I made there, writing a 4 instead of a 3, if you do that mentally, you're going to miss the problem. Because you can't see the mistake. You can't evaluate your mistake. That's one of the ways, one of the many ways that just doing things mentally can lead you down the wrong path. All right, so the first one's 3 times 16, which is 48. That's 6. 4 times 3 cubed. It's 4 times 27, right? 4 times 27 is 108. Okay? So this is going to be 54 minus 108, which is negative 54. Now, if the goal is just to put a symbol in here, we can go ahead and do it. Because this is positive.
So then you push this way.
Holy smokes. We can go ahead and do this. All right.
Feel okay there, Mr. Hank?
I'm okay. You know, I had a little too much sweet tea at lunch. It's got me a little loopy. All right, let's do this. Because I'm not getting these problems, I think maybe could be a little bit more challenging for you guys. Let's evaluate 3ab squared minus b squared if a equals negative 2 and b equals 7. That's too big. Let's do a smaller number. We're not using calculators here. We'll just do a smaller number. Now, this is going to address the question that you asked just a moment ago, Hadley. Yeah, I think. Okay, when we make our substitution, we're going to do 3 times negative 2 times 3 squared minus 3 squared. Is this kind of like the question you were asking earlier, Hadley?
Kind of. It wasn't like exponents. It was just like I kind of get it.
Yeah. Everybody evaluate this and see what you get. What a dork. All right. So what do we get? Negative 63. Did everybody get negative 63? Okay, so we do have some different answers, right? I've heard about 4 different answers. So let's go through the evaluation process here. 3 squared is 9. So this is going to be negative 6 times 9, which is negative 54. All right? Negative 54. Now here's the big dilemma, right? What's next? Minus 9, right? That's where if you don't know the place where that negative sign belongs, if you square that negative sign, you get an incorrect answer. We're not going to square it.
But if it was like negative, like minus 9 times like 6, wouldn't that be like negative 54? Wouldn't you include minus sign as a negative sign?
Where?
Like, if that was negative 9, or like minus 9 times 6, wouldn't you include the negative sign?
It wouldn't really matter. Even if you do it positive 9 times 6, that negative number still wouldn't be there.
Which negative number are you talking about?
Like,
If there was like a times 6 after negative number.
I know, but like,
If there was a 6 here,
I don't.
is that what you're saying? Yeah, so it's still negative 9 times 6, which is
Okay, like
54. Or you could just say, okay, it's minus 9 times 6, but 9 times 6 is 54, and you still have negative 54.
But you wouldn't include the negative.
Yeah, it's there regardless.
But you wouldn't multiply with it.
You could. If you multiply with it, what do you get?
The same.
What's negative 9 times positive 6? Negative 54. Or minus positive 9 and positive 6 is positive 54, but the minus is still there. So it's either way. Yes, Abby?
I did 3 squared, but why wouldn't you do negative 3 squared?
Okay. Because this negative sign belongs to this whole expression, that whole term. Okay?
Its own term.
Do you have to have it in the parentheses for it to be like that?
Yes. So let's have a look at a problem where the negative sign wouldn't be there or would be there. Liam, what you got?
If it was negative 3 to the second power, then wouldn't you be multiplying negative 3 should be positive?
Are you asking here? This is the question I've been trying to get to right here. Are you asking me if we should have done negative 3 times negative 3? Okay, and that's exactly, let's see, if we did 3 times negative 2 times 3 squared minus 3 squared. Right? I'm putting the 3 in the place of b. Okay? How many negative signs are here? There's only one negative sign, right? It's a subtraction sign that belongs to this term. So 3 squared is the only thing I'm squaring. Right? Now, where this would change is if we had an expression that was this same expression, and let's make, instead of b being a positive number, let's make b a negative number. Okay? So you with me there? Now, Liam, when you make this substitution, you'd have 3 times negative 2 times negative 3 squared plus negative 3 squared. Now we're squaring the negative. There's two negatives there. In the previous way it was written, there was only one negative sign, only one subtraction sign. Abby?
Say when you were say you didn't have to substitute, and so you didn't have the parentheses, would you be doing negative 3 squared, like with the original problem, if you didn't have the parentheses?
All right, let's go back to what the original problem was. And, well, what were you saying now?
If you had the original problem, but you didn't have the parentheses around the b squared, would you be doing negative 3 squared?
No. There's still, when you make your substitution, what's the value of b? What's the value of b? 3. So that'll be 3 squared. And the value of b, see this negative sign comes down, right? And it's affecting the term behind it. But what I'm substituting for b is just 3. So it's kind of safe to always use parentheses when you make substitutions so that you get clarity on what you're squaring. What are we squaring there? We're squaring b, which is positive 3. I'm not squaring negative 3. I'm squaring b, which is positive 3. Okay? Now, if I rewrote this problem as 3ab squared plus negative b squared, then I would be squaring negative b, which would be negative 3 in that case. All right, so that's, and I wanted to spend some time there because there's always confusion related to that. Where is the negative sign and what are we squaring? We got one more example to look at. A cell phone company charges $20 monthly fee and then 45 cents per minute. Write an expression that you could use to find the total amount to charge for each month. So let's stop right there and do that. What would the expression be for the total charge for each month?
45 in
20 times 45 times
45 times
0.45 times
0.45x.
Okay, so it's $20. And what are we doing with that $20?
Plus
We're adding
variable
0.45 times m or x. M, let's use m because we're talking about the number of minutes. All right? And then use the expression to determine how much the company would charge for 200 minutes. Okay, for 200 minutes, what would I do? Make the substitution 0.45 times 200. That would equal $9.
Yes,
You sure about that? I think it's $90. 200, right, it's 100 times 2. The 100 will move the decimal 2 places and then multiply it by 2. $90 plus $20 is $110 for the total bill. Okay? So that's just an example of where we might think of things in terms of an algebraic expression and do it. Now, if our cell phone bills were only that simple, but they're not. I don't know if you've looked at a cell phone bill lately. You got to be a rocket surgeon to get anything. Yeah. Rocket surgery. Yeah. All right. Homework is page 45, A through D, 1 through 11 odd, 12 through 17, and 22 through 26.